Assalamualaikum and a very good day to Dr. Shara, our lecturer for CPD 30303 Pilot Plant Operation 2, and my fellow friends. In this video, our group have choose Tanjung Bin Power Plant as our model plant. Let me introduce myself and my teammates. I am Intan Izzati and my teammates are Nurul Khayrin, Tengku Nazrin, and Ain Nur Atiqah. So now, let's talk about the process flow of this power plant in generating electricity. A boiler for a modern 700 megawatt turbo generator at Tanjung Bin can produce more than 2,360 tons of steam per hour. For best combustion, coal is pulverized before it is being blown into the boiler in a stream of preheated primary air. Pulverized coal burn in the boiler furnace chamber produces great heat to convert water circulating in the boiler tubes into high pressure steam. The electrostatic precipitator system between the boiler and the stack extracts up to 99% of ash particles from the boiler flue gas. The particulate-free flue gas is finally washed in the flue gas desulfurization to remove harmful sulfur dioxide from exiting the stack. Coal produces ash as the product of combustion. Fly ash is collected in the ESP and transmitted into the ash silos, while the bottom ash is sent to the ash point. Next is the steam turbine. The high-pressure steam injected into the turbine turns the fan-like turbine blades mounted along the main rotor of the turbine. This rotating rotor extends like an axle into the electric generator. For maximum efficiency, the steam is reheated in the boiler after its energy is partially spent driving the first stage of the turbine. From the reheater, the steam will then pass through the second stage of the turbine, and the steam is then condensed back to water for reuse as it passes over a series of condenser tubes through which cold seawater from main cooling water system is circulated. Next, generator. The generator consists of two main sections. The first, the revolving section, which is also called the rotor, which is directly coupled to the steam turbine shaft, and the starter. The starter is a series of coils wound cylindrically in the stationary shell around the rotor. So the rotor is an electromagnet that revolves at 3000 RPM, which generating an alternating current in the stator. So the direct current supply to the rotor comes from a separate static exciter. And the last one is transmission. So electricity is produced in the generator at 26,000 volts. It is then passed through a generator transformer, which steps the voltage up to 500,000 volts. From the transformer, the electricity is transmitted into the switchyard, and from the switchyard, the electricity is transmitted into the national grid system. Okay, so in this power plant, there is also a refrigeration system, which will cool body temperature or maintain the temperature at below the surroundings, and the heat must be flow from the equipment at low temperature to the surroundings at higher temperature. So they use the thermodynamics principle, which is to achieve the thermodynamic equilibrium. So the thermodynamic principles that applies in this system is a reverse Carnot cycle. So the objective of reverse Carnot cycle is to using work. So the work serves to take the heat from the reservoir and will redirect it to the source. And the output of this cycle might be cooling or heating. So in this plant, it should be cooling. Okay. Alright, so the function of refrigeration cycle in this plant is to cool down the air streams and to achieve a higher efficiency of electricity. As we all know, that electricity generation is often based on the combustions of different fuels. For example, in this power plant, we use coal as the fuels. So to achieve a higher efficiency, inlet air must be determined in determined conditions. So if the temperature of the inlet air is too high, so the density decreases and it will suffer a decline in the electric production. So to avoid this problem, this refrigeration cycle is used to cool down the streams. And the other function is to cool down the generators, as the generators will generate heat when operating. So to minimize the maintenance operation, refrigeration systems are necessary. Okay, next, let's move on to the component of refrigeration cycle. So the main component in refrigeration cycles are compressor, condenser, evaporator, and expansion valve. So compressor is used to reduce the pressure in the evaporator and increase the pressure of the vapor being transferred to condenser. So this compressor will use the work such as electricity. And next, the condenser. A condenser is where the high pressure vapor condenses and will reject heat to the surroundings. Next is the evaporator. So evaporator is where the heat is taken from low temperature region as the liquid evaporates at low pressure. And lastly is the expansion valve, which controls the flow of liquid refrigerant and reduces the pressure of the refrigerant.
Other than refrigeration system, there's also a steam generator, which is the use of the steam generator in this power plant is to produce steam of specific quality at the desired production rate. It is to contain the combustion process to facilitate heat transfer from the flames and hot gases to the water and steam tubes. It is also to facilitate stable combustion condition for the coal. And let's go to the function to the component of the steam generator system. Therefore, we will look at the picture given. The picture shows there is a few key components of boilers. There's burner, heat exchanger, supply lines, return lines, firebox, refractory, circular pumps, condenser, economizers, and superheater. And let's go one by one. First of all, we will start with burner. The burner is the component of the boiler that provides the heat that heats the water of the system. The fuel used can be natural gas or oil. Next, we will go to the heat exchanger. Heat exchanger of boiler allows the heat from the burner to heat the water in system. The job of the heat exchanger is to carry the heat from the burner to the water without having direct contact with the water. It is similar idea to boiling water in a pot. As for the supply lines, it is the hydronic heating system used piping to deliver the heated water or steam to the distribution points, and the supply lines are the pipes that distribute the hot water or steam to distributor. If we have the supply lines, there must be a return lines, where when the water cools or the steam cools and changes states back to water, the return lines bring this water back to the boiler for the reheating. It also have a firebox. Firebox is where the fuels of the system meets the air to create a flame. Other than that, there's also refractory. The function of refractory is actually it is used for filling any gaps or any opening that may be around the firebox. This helps to ensure the fire stays in the firebox. And there's also a circular pumps. It is used to push the hot water or steam from the system to the heat distributors in our homes. And there's also a condenser. Condenser tanks are only used in steam boiler system and not in hot water and hot oil boil, because here the fluids always is on liquid form. There's no steam form, or we call it as air form. The construction of these two types of tank is almost identical, but as their name suggests, they are used for different purposes. There are two primary principles that are used with this form of tank design, which is thermal and vacuum. Other than that, there's also economizer. Historically, economizer have only been used in large-scale power plants, which is also used in this power plant. However, the demand for more efficient boilers within industry and marine means that economizer are now far more commonplace. An economizer is a heat exchanger that is placed in the exhaust from the boiler or in the exhaust funnel of the main engine of the ship if it is in the ship. The pump requirement differ greatly depending on the way the economizer is installed. Last and not least is a superheater. It is integral part of the boiler and is placed in the path of the hot flue gases from the furnace. The heat recovered from the flue gases is used in superheating the steam before entering into the turbine, which is the prime mover.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Nazrin. Now I will present about the steam generator turbine works. Base thermal power plant together produce almost half of the world power plant convert thermal energy in the steam to mechanical energy. We will explain the inner working of the steam turbine and why they are constructed in the manner that are in a step-by-step logical manner to understand. It's a basic working. Let's first observe on one of their blades. You can see that the blade of the steam turbine has an airfoil shape. When the high energy fluid pass over it, this F4 shape will create a pressure difference. This will subsequent create lift force. The lift force will rotate the turbine. In short, the energy in the fluid transfer to the mechanical energy of the rotor to further operation. Let's understand fluid energy in greater depth. A fluid has three forms of energy due to its speed, pressure, and temperature. As the blades absorb energy from the fluid, all three forms of the energy come down. The low velocity jet is of no use to produce effective lift force. To increase a velocity, the fluid is passed through a stator section. The stator set is stationary and attached to the turbine casing. You can see that flow area decreases along the stator and the speed thus increases. In short, the stator acts like a nozzle as the speed of the jet increases. In the stator kinetic energy, as there is not need energy transfer in the fluid stator section, the pressure and temperature of the jet should decrease to keep the total energy constant. Now, the next row of rotor is at the stator. Also make sure that the fluid coming out of the will be at an optimum angle of attack to the rotor set. After that, another nozzle set at many such sets are used in a steam turbine.
Assalamualaikum, my name is Nurul Khayrin and I'll be explaining about compressor. Compressor function to impart kinetic energy into the airstream by increasing the velocity of the air using a rotating element, and then converts this kinetic energy into potential energy in the form of pressure. Important component in compressor is first, inlet. The inlet to a centrifugal compressor is typically a simple pipe. It may include features such as a valve, stationary vents, or airfoils, which used to help swirl the flow, and both pressure and temperature instrumentation. Second is impeller. Impeller contains a rotating set of blades that gradually raises the energy of the working gas. Next is the diffuser. Diffuser is used to convert the kinetic energy in high velocity of the gas into pressure by gradually slowing the gas velocity. Lastly is the collector. To gather the flow from the diffuser, discharge annulus and deliver this flow to a downstream pipe.
Okay, so now is the NDT application for the system in this plan. So since there are four components, so these four components will undergo non-destructive testing to avoid any failures during operation. So the first one is condenser and evaporator. Condenser and evaporator will undergo eddy current testing, which is particularly well suited for detecting surface cracks, but can also be used to make electrical conductivity and coating thickness measurements. So a small probe is scanned over the part surface in an attempt to detect a crack. Next is the compressor. So compressor will undergo the pressure vessel inspection. So the failure of pressure vessel can result in the rapid release of a large amount of energy. To protect against this dangerous event, the tanks are inspected using radiography and ultrasonic testing. And lastly, the expansion valve will undergo hydrostatic testing.
The application in the steam generator, it is mostly used on the boiler itself, which is the shell part, flat part, steam drums, tubes, welding of the top tube sheet, welded stays of tube sheet, and stable. And the recommended of NDT method that uses visual ultrasonics, radiography, detection of acoustic emission, liquid penetrance, and magnetic particles. Then there's a few others that we use for the NDT application in the steam generator.
So the NDT application for compressor is mechanical running test, aerodynamic testing, impeller overspeed test, casing inspection for the casing of the compressor, gas leakage test, and lastly the vibration test and analysis. Okay, the next suggested NDT in this plan is the wall thickness measurements and scale detection using ultrasonic techniques. Periodically, boiler units are shut down for capital overhauling, the vital time for NDT operations. Operations for wall thickness measurement and scale detections are conducted on various boiler accessories like superheater, economizer, penderator, and other boiler accessories which remain in contact with steam. Second is remote visual inspection, which detect any crack or surface failure. Third is the vibration analysis. In order to design machineries to eliminate the vibration-related problems, this action is to prevent any serious damage. Lastly is the X-ray. In order to conduct acid cleaning or to perform further research work in the chemical branch, by knowing the composition of the scale The composition of compound to be used during acid cleaning in capital overhauling can be decided.